Okay, we are in day 3 of Unit 3, 3, and we're going to be talking about inverse functions, like functions that are inverses of each other. And you may remember some things back, like if you take f of f inverse, then you get x. Okay, so lots of things from Algebra 2 and pre-calculus that we want to remember about inverse functions, but we are going to talk about some rules with differentiating those. Okay, so this is what I was kind of saying. If f and g are inverse functions, then when you compose them, you get to x. What that kind of means is that line y equals x. So for instance, e to the x and the ln of x are inverses, which means they're symmetrical over y equals x. So if I was to talk about an inverse notation or an inverse function, then what I do, if I know a point on f, then on the inverse, it's flip-flopped between the x and the y. So the domains and the ranges are flip-flopped. I'm so sorry. Okay, so if I have the point 2, -3 on f, then what point would I have on the inverse function? I'd have -3, 2. So here is just a tabular representation of some points that I know are on f of x. So here, if I kind of look at this, some of the things that I want to know, f inverse of x here is kind of talking about like the y when I'm looking at it, okay? So if I know that 10, 15 is a function here, oh my gosh, is a point on this function, then I'm going to know that 15, 10 is on the inverse. So if I kind of think through that, I'd say the inverse of 15 would equal 10. Just like f of 10 would equal 15. So it's just another way to kind of see that flip-flop. So here, if I know this, then I know f inverse of 17 equals 20. So if I wanted to find f inverse of 7 here, I don't plug 7 into the x's. I put 7 equal, and I solve for x. So we're looking for when 7 equals the f of x. All right, so let's go ahead and just kind of see. That's always going to kind of be the first step. So I want you to actually go find f inverse of 7. So where does this function equal 7? I'm going to get it equal to 0, so subtract that. This is factorable. Do not write what I write. You factor your own. I like to guess and check. I think it's quick. Okay, I can see that these two would give me a 6, and then these would give me a -1, and that would give me a 5, and they multiply to -3. But you do it how you do it, okay? So here I can see that x could be 1/2 or -3, but they told me x has to be less than or equal to -5/2. So f inverse of 7 can only be equal to the -3. Okay, so all of that is review. So we're going to look at the calculus connections. If f is continuous on the domain, then f inverse is also continuous on that domain. If f is increasing or decreasing, then f inverse is going to be increasing, decreasing. So just some things with the differentiability, okay? But this is what we really want to know. That if I am looking for the derivative of an inverse here, That is the same as 1 over the derivative of the original function of the inverse function at that same value that you're looking to derive for. So I like to think of this in 3 steps. First, find f inverse of x. So that's kind of what we just did, okay? I'd say, where does f of x equal that value that we're looking for, and get some answer. So where does f of x equal this guy? Then we're going to take the derivative of that. So we're going to find f prime of whatever we just found. And then we get a different answer. Then we're going to do 1 over the answer we just got, because it's all in the denominator. And you're like, woo, okay, let's practice. So first step here, I'm looking for the inverse's derivative evaluated at 2. That's what we're trying to find. So the first step is to take the f of x and see where that is equal to. Solve for x. There's step 1. Step 2 is to find f prime of that number. So here I have to find f prime of x, and then get f prime of the 8. Or 2, 4. And then my third step is to do 1 over what we just found. So this derivative equals 4. Okay. This is from 2007, number 3. Tells me a lot of information, gives me the function of h, says g inverse is the inverse function of g, so I'm given those two. Write an equation for the line tangent, so I want an equation of a tangent line for g inverse of x at 2. So we need a point and we need a slope for g inverse of x when x equals 2. Okay? Well, I'm going to need the point, so I know that if I'm looking when x is 2, what is y? So here I am given g, so we're kind of looking on g, we're looking for where it's switched, where the y value is 2, what's the x? So I'm not plugging in 2 to g, I'm looking for where I get an output of 2, and that happens at 1. So there is my point. Now to get the slope, I need to get the derivative. So that's where we do our 3 steps. Where does g of x equal to? And we've already found that. That's where x is 1. Step 2. What is g prime of 1? That is 5. Step 3, take your answer and do 1 divided by that. There's my slope. So this derivative of the inverse evaluated at 2 is 5. So now we can do our point, is 1/5. So now we can do our point slope. Okay. All right, I want you guys to go ahead and try this next multiple choice example. Think through it. All right, so they told me that these guys are inverse functions. That's what this is basically telling me here, that f and g are inverses because their compositions of each other equals x. And then they told me f of a equals b. So if I know f of a equals b, and I'm looking for like the derivative of the inverse function, which is the same as saying g prime of what? So if I know that f of a equals b, right, then I can go and find that g of b equals a, because we just flipped that domain and range. So then I have to look and see, they gave me f prime of a equals c. So the next thing I would kind of look at is say, well, what's g prime of b? And that is 1 over c. That's the same as saying 1 over f prime of a. Makes sense? I hope so. That is c. If that didn't make sense, then let's talk about it in class. Okay, see if you can get this one. So work through it and see if you get D. I really want you to try that one on your own. And again, if you need more help, we can do more together in class, okay? All right, kiddos. See you in a little bit. Maybe. Maybe it's late. Maybe it's early. I don't know what it is right now for you. All right, I'll see you the next time I see you.